As of January 1, 2020, New Jersey mandates the installation of arc fault circuit interrupters, also known as AFCIs, in bedrooms. This requirement is implemented to enhance electrical safety and prevent electrical fires, and it applies to both new construction projects and major renovations that necessitate a permit. The specific regulation stipulates that the AFCIs must be installed on 15 amp and 20 amp branch circuits that provide power to outlets or devices located within bedrooms. This encompasses a wide range of electrical points, including lighting fixtures, electrical receptacles commonly known as outlets, and any other electrical devices present in the bedroom area. The purpose of AFCIs is to detect arc faults, which are dangerous electrical conditions that can lead to fires. Arc faults occur where electricity strays from its intended path and creates an unintended electrical discharge, generating heat that can ignite surrounding materials. AFCIs are designed to quickly interrupt the circuit when an arc fault is detected, thereby preventing the buildup of heat and reducing the risk of fire. The installation of AFCIs is an integral part of modern electrical safety standards, and it plays a crucial role in safeguarding homes and occupants from electrical hazards. By adhering to the New Jersey Electrical Code and ensuring the proper installation of AFCIs in bedrooms, homeowners can significantly minimize the risk of electrical fires and create a safer living environment. It's important to note that the AFCI requirement in New Jersey is based on the National Electrical Code, specifically Section 210.12, which addresses arc fault circuit interrupter protection. The NEC, or National Electrical Code, is a widely adopted standard for safe electrical installation and maintenance. It is important to understand the nuances of the NEC to ensure compliance. It is regularly updated to reflect new technologies and safety practices. The AFCI requirements of the NEC are intended to provide enhanced protection against electrical fires by detecting and interrupting arc faults, which are unintentional electrical discharges that can occur in a circuit. These arc faults can generate significant heat and ignite surrounding materials, leading to a fire. AFCIs are designed to differentiate between normal arcing that occurs during the operation of certain devices and dangerous arc faults that pose a fire hazard. There are several types of AFCIs, including branch circuit AFCIs, which protect the entire branch circuit, and outlet branch circuit AFCIs, which protect the branch circuit downstream from the point of installation. The NEC specifies the locations where AFCI protection is required, and these requirements vary depending on the occupancy and the type of circuit. In dwelling units, AFCI protection is typically required for branch circuits supplying outlets in bedrooms, living rooms, dining rooms, family rooms, recreation rooms, and other similar areas. The specific requirements for AFCI protection can be found in NEC Section 210.12. It is essential to consult the latest edition of the NEC and any applicable local amendments to ensure compliance with the current requirements. Proper installation of AFCIs is crucial for their effective operation. AFCIs should be installed by qualified electricians who are familiar with the NEC and the specific requirements for AFCI protection. The installation should be performed in accordance with the manufacturer's instructions and all applicable codes and standards. AFCIs should be tested regularly to verify their functionality. The NEC requires that the AFCIs be tested upon installation and periodically thereafter. The testing procedure typically involves using a test button on the AFCI to simulate an arc fault and verify that the device trips and interrupts the circuit. It is important to keep records of AFCI testing and maintenance to ensure that the devices are functioning properly. In addition to the NEC, there may be local codes and regulations that govern the installation and use of AFCIs. It is essential to consult with local authorities and electrical inspectors to determine the specific requirements in your area. These local codes may impose additional requirements or restrictions on AFCI installations. Staying informed about the latest codes and regulations is crucial for ensuring compliance and maintaining electrical safety. The NEC and other electrical codes are constantly evolving to address new technologies and safety concerns. It is important to stay up to date on these changes and to seek professional guidance when necessary. This will help you to ensure that your electrical system is safe, reliable, and compliant with all applicable requirements. The presence of AFCIs in a home's electrical system can significantly reduce the risk of electrical fires and provide added protection for occupants. By detecting and interrupting arc faults, AFCIs can prevent the build-up of heat and the ignition of surrounding materials. This can help to save lives and prevent property damage. While AFCIs are not a substitute for other electrical safety measures, such as proper wiring and grounding, they provide an important layer of protection against electrical fires. They are an essential component of a comprehensive electrical safety plan. If you are unsure about whether your home has AFCIs or whether they are properly installed, it is recommended that you consult with a qualified electrician. An electrician can inspect your electrical system, verify the presence and functionality of AFCIs, and provide recommendations for improving electrical safety. They can also answer any questions you may have about AFCIs and other electrical safety topics. The installation of AFCIs is a relatively simple and inexpensive way to enhance electrical safety and protect your home and family from electrical fires. If your home does not have AFCIs, it is recommended that you consider having them installed by a qualified electrician. This can provide peace of mind and help to ensure that your home is safe from electrical hazards. The NEC AFCI requirements are designed to reduce electrical fires. AFCIs are designed to detect and respond to dangerous electrical arcs, which can cause fires. Electrical arcs are unintended electrical discharges that can occur in a circuit. They can be caused by a variety of factors, such as damaged wiring, loose connections, or faulty appliances. When an electrical arc occurs, it generates heat, which can ignite nearby materials and start a fire. AFCIs are designed to detect these dangerous electrical arcs and quickly shut off the circuit, preventing a fire from starting. The NEC requires AFCIs in many locations throughout the home. The NEC requires AFCIs in many locations throughout the home, including bedrooms, living rooms, dining rooms, family rooms, and other areas where people are likely to be present. This helps to protect people from electrical fires no matter where they are in the home. AFCIs are required for both new construction and renovations. The NEC requires AFCIs for both new construction and renovations. This ensures that all homes, regardless of age, have the protection of AFCIs. AFCIs are relatively inexpensive. AFCIs are relatively inexpensive, making them an affordable way to protect your home from electrical fires. The cost of an AFCI is typically around $20 to $30. AFCIs are easy to install. AFCIs are easy to install, and a qualified electrician can install them in a matter of minutes. This makes it easy to add AFCIs to your home, even if you are not a qualified electrician. AFCIs are a good investment. AFCIs are a good investment for any homeowner who wants to protect their home from electrical fires. They are an affordable, easy to install way to add an extra layer of protection to your home. If you are concerned about electrical fires, you should consider installing AFCIs in your home. Contact a qualified electrician to learn more about AFCIs and how they can protect your home. Also, ensure you are using 14/2 or 12/2 wire appropriately in the dwelling, and you are not exceeding voltage drop over the total distance of the wire run, while also ensuring you are choosing the appropriate wire gauge for the application. 14-gauge copper is typically used on 15-amp circuits, and 12-gauge copper is typically used on 20-amp circuits, while 10-gauge is typically used on 30-amp circuits. Exceeding the ampacity of a wire will cause it to overheat and potentially lead to a fire. Voltage drop is also another concern if the wire run is too long. You can use an online voltage drop calculator to determine whether or not the conductor size is large enough for the application.